Hello, everyone. Today, please turn to 5.4 day one. Today, we're going to be evaluating different kinds of roots and also kind of on the flip side, using rational exponents. So take a second, pause your video. I really would love it if you guys would try the Ignite at the top of the page. All right. Hopefully you got, if you look at the top one, if you type both of those into your calculator, fun fact, you actually get the same answer. And that's because in radical world, whenever you have whatever number is kind of whatever square root you're taking. So, like for example, if you're not taking a square root, which remember, if there's nothing written there, it's implied that there's a little two there, but that's the number that you're actually raised to in this particular one. So when we deal with exponents and square roots, there actually is a way for us to write any exponent, even or any square root or cubed root or fourth root as a fractional exponent. They're essentially the same thing. So for example, if I had the cubed root of 16, the equivalent expression of that is we take whatever is out of the inside and we raise whatever number is out here. And that's the number that goes on the bottom of the square root, or cubed root in this case, or whatever kind of root it is that we're taking. So what we're going to be doing today first is just practicing kind of the rewriting step. So for example, if you look down at the first and second example here, it's the directions say our goal is to rewrite the expressions as a square root expression. Now keep in mind, it doesn't have to be a square root. It depends on what kind of root you have. But if we have something like this, where again, it's a fractional exponent, that means we can rewrite this as some sort of square root. Now, for here, remember whatever goes on the denominator, that's the kind of square root you have. If it's a 2, that's the one that we usually don't write. The one with no number is always implied to be a 2 on the outside. And then whatever number is being raised to the power, that is what goes on the inside. So same thing's kind of true for this one right here. We have our square root. Now, this one isn't going to be a square root because what number is on the denominator? It's a 7. So we're actually working with a 7th root. And then the y and the top, what's on top of the fraction, the numerator, that is what goes inside. Now there is a second way to rewrite this, and that's where you focus on, instead of the square root being kind of over everything, you can move that exponent out. Ooh, it's supposed to be a 3. You can move that exponent out here and keep the 7th root of y on the inside. Technically, there are two equivalent ways of writing the same thing. Okay, so pause your answer, or pause your video and try examples 3 and 4. All right, final answers are up. If you guys notice, if your final answer for number 3, you should have had the denominator out here on the outside, and then the root and the base are going to be underneath. If you chose to move that kind of the exponent on the numerator on top out, that is also okay. Those are interchangeable ways to write the same exact thing. Okay, same thing with number 4. The 7, since that's on the denominator, that goes outside. And the number on top and the base, those are going to go together on the inside. Okay, now we could go the other direction. We could have convert our square root or our rational exponents expression and rewrite it using roots. So kind of the same thing holds true. We have our 741. Whatever number is underneath or is outside of your square root, that is going to be the number that is going to go on the denominator. And the 2 comes up top. Final answer, you'd say 741 raised to the 2/3. If it's one like number 7 here, where there is no number here, remember that's always implied to be a 2. So here, where technically this is asking us to take the square root of 91, which just means we're going to take 91 and raise it to the 1/2. All right, so pause your video now, and I want you to try examples 6 and 8. All right, answers for 6 and 8 are up. You should have got 124 raised to the 7/6 for number 6, and 276 raised to the 1/3. Now, our next goal is going to be to really work on actually evaluating some of those exponents. So if we look at example 9, for example, the cool thing about this is that when we rewrite this, usually we want to break up that 3/2, and we're always going to rewrite it so that it's in our square root form. So the 49 is going to go underneath the square root, I know it's a square root because the denominator is a 2, which again, a lot of times we don't write. And then we're going to take that 3 and put it there. Now, when I know square root of 49, remember you can always write it like this as well. And you can really choose to kind of do either method first. You could either choose to raise that number to the power first, or you can take whatever the root is first. And the awesome part is it doesn't matter which one you do first. For me, I think the square root part is easier because I know what there is a number out there that's squared that gives me 49. And that answer is 7. I'm going to keep the parentheses, keep my cube that's there. And all I have to do now is do square root of 49. I'm going to take 7 and I'm going to raise that to the third power. So 7 raised to the third power is going to end up being 343. All right. So when you have something like number 11, I figured I'd mention just as a recap what negative exponents do. Remember, negative exponents, all those do is move the number to the bottom half of the fraction. And we still kind of tackle this the same exact way. Once you move it to the bottom, the exponent becomes positive, and then we go to our rewrite step. The denominator becomes the kind of root that you're taking, and the top number and the power, those are what goes on the inside. Now, like I said before, you could do the square the fourth root part first and then cube your final answer. Here, if you want to do the opposite, if I take 16 and I cube it, that's going to give me 4,096, which then, of course, we take the fourth root of, and we get our final answer of 1/8. All right. So pause your video now and try examples 10 and 12. All right, final answers for 10 and 12 are up. You actually should have gotten 32 for both of these answers. No matter if you do the root first or you do the exponent first, the awesome part is you still get the same answer. Now, whenever we work with square roots and or exponents like this, the goal is to kind of use these to help us actually solve equations. Because if you'll remember, those two operations are inverses of each other. So anytime we want to get rid of a power of some sort, roots are always the answer. Anytime we want to get rid of a square root, powers are always the answer. So for any time we solve an expression that has any sort of roots that are kind of like higher than 2, the goal is always to isolate whatever is that's being raised to the power. So for example, if we look at like number 13, I have a 4x to the 5th equals 128. My goal is always going to be to get the thing being raised to the power alone. So my first step on this one is going to be to divide both sides by 4. And we're going to be left with x to the 5th equals 32. Now that we're at this stage, now we can go ahead and undo any of the powers. And we do that using whatever root undoes the power. So if I have x to the 5th, that tells me I'm going to take the 5th root. And I'm going to do it to both sides because I'm working with an equation. So 5th root of something raised to the 5th, that's going to cancel. And all we now have to do is focus on taking the 5th root of 32. All right. So if you hit the math button on your calculator, you can get the 5th root here. You're going to choose option number 5. And that lets you kind of choose whatever power you want to take. So I'm going to take the 5th root of 32. And our final answer is going to be 2. All right. So even if it looks like something like number 15 here it looks a little weird, but again, we're looking to get the thing that's being raised to the power alone. Here, there's nothing out in front. There's nothing being added or subtracted on the end. Here, I can go ahead and take my 3rd root right now. I'm raising it to the 3rd power. I'm going to take the 3rd root. The power cancels out with the root, and we're left with what's on the inside. And all we really have to do is take the cubed root of 20. Now, if you take the cubed root of 20, this isn't exactly the nicest number, but that's okay. We're left at 2.71. We'll round to 2 decimal places. And then we solve like normal. Subtract 5 from both sides. And we're going to be left with our final answer of negative 2.29. All right. Pause your video and you can try number 14. All right, final answer is up. You should have got x to be plus or minus 2.22. Now, if you're wondering where that plus or minus came from, remember this is kind of more particular to any time we deal with even powers. But if you'll remember, if I take, we're saying x squared equals 16, for example, when we take the square root of two numbers, we get two answers. Because you're saying what squared gives you 16, there's always a positive and a negative answer to that question. So just to kind of keep in mind, the reason I didn't do that with the first two is because those had odd exponents. Anytime you have an even exponent, it just means your final answer is going to have a plus or minus with it. Okay. So if you feel ready, you guys can go ahead and start working on the homework. If you want to give the real world application a shot, or you want to give the You Try Nows a shot, go ahead and do so now.